Hey Geometry, Lesson 12, dividing segments proportionately. You know, a segment, and dividing it, let's say I want halves, or thirds, or fourths, etc. So dividing segments proportionally, using what we know in geometry and ratios and such. A lot of the lesson today is not in your classwork, so you can grab a sheet of paper and follow along, or just sit back and enjoy the ride. When I get to the end of the part that's not in your classwork, we'll have a few equations that you can jot down. But if you don't mind, just sit back and enjoy just going through the lesson of how to come up with these equations using coordinate plane and segments. Awesome, let's go. All right, so here I have plotting the points, -4, 5, and 12, 13. Let me get another marker here. There we go. Draw the slope triangle. I've never referred to it as the slope triangle, but it makes sense. So I'm going to make a triangle out of the slope. I hate drawing straight lines on this thing. We're just going to erase that. There we go. And I'm going to label this C. What is the length of segment AC? I've got 4 plus 12, so 16. And what is the length of segment BC? 1, 2, 3, 4, 5, 6, 7, 8. Awesome. Mark the halfway point on segment AC and label it point P. So half of 16 is 8, so 4 and 4. Point P. Sorry, I had to sneeze. What are the coordinates of point P? So I have over 4. We're not going to draw it there, though. 4 up 5. Mark the halfway point on BC and label it point R. So this is 8 segments. I'm going to go up 4. 1, 2, 3, 4. 5, 6, 7, 8. Yep, I want to make sure I was halfway. Marking that point R. And the coordinates of point R are over 12 up 9. Draw a segment from P to AB. Oops, I was trying to make it thicker. Let's just do this. And let's see, draw a segment P to AB, perpendicular to AC. Perpendicular to, perpendicular. Mark the intersection point M. What are the coordinates of M? I am over 4 up 9. Draw a segment R from R to AB. What do you notice? Well, I notice that it meets at M. Describe to your neighbor how we found point M. Do not leave your home. Run next door to your neighbor and tell them how you found point M. We found point M by connecting the dots. It's the intersection of 2. So it's the halfway point of the x distance and the halfway point of the y distance is what I want you to notice. So the halfway point of the x distance, the halfway point of the y distance drew perpendicular segments, and we joined A and B where they connected, okay? So point M is called the midpoint of segment AB. This is important. That's why it's italicized. So you might want to write that down. Midpoint is halfway between points A and points B. Cool? All right, let's move on. All right, we aren't done yet, though. I needed another slide, right? So look at the coordinates of the endpoints and the midpoint. Can you describe how to find the coordinates of the midpoint, knowing the endpoints algebraically? If I look at the coordinates of A, let's see, we wrote down A, it was at the beginning, negative 4, 5, and B was 12, 13. And then point M was, let's see, point M, 4, 9. So algebraically, how can I come up with M when I know A and B? Well, I can just average the x's, so negative 4 plus 12 over 2, and 5 plus 13 over 2. That gives me 8 over 2 and 18 over 2, which is 4, 9, which is what I got. Okay, that is actually called the midpoint formula. Okay, but of course we can't do everything the same way every time. We need to show you guys different ways to do stuff. Because sometimes we don't want to find the midpoint, we may want to find the 2/3 point, or the 4/3 point, or the 5/4 point, etc. So we're going to give you a few different options. So let's try to find the midpoint a slightly different way. Starting at point A, describe how to find the midpoint. So starting at point A, find the horizontal distance from A to B. Okay, from A to B. Horizontal distance, which is going to be 12 minus 4. So starting at point A, find the horizontal distance from A to B, which is going to be 12 plus 4, which is 16. Divide by 2 equals 8. And add that value to the x-coordinate value of A. Not sure I like this way any better. Now to find the y-coordinate of the midpoint, find the vertical distance from A to B. So we just did horizontal, now we're finding the vertical distance from A to B. So I've got 13 minus 5 equals 8. Divide by 2 equals 4. And add that to the y-coordinate of B. Okay, that I don't like that. But if I write it as a formula, it makes sense. So let's write it as a formula. I have negative 4 plus half of 12 minus a negative 4, which is 12 plus 4, comma, 5 plus 1/2 of the distance. So that gives me my x value and my y value. How would this formula change if we started at point B instead of point A? So if we started at point B, instead of adding, we would have to subtract. Okay, now write a general formula for the midpoint of a segment with endpoints x1, y1 and x1 or x2, y2 using the average formula and then the formula starting with endpoint A. So we are using this formula, and then we're using this formula. Okay, so I'm writing it two ways. So way one is going to be add the x's and divide by 2 and add the y's and divide by 2. The next method would be x1 plus half x2 minus x1 comma, y1 plus half y2 minus y1. Honestly, you can pick which either one you would like. I know which one I use, but I don't want to sway you. I'm going to point out that I can also rewrite this one a little bit different. I can do 1/2 x1 plus x2, 1/2 y1 plus y2. And I'm only calling that out because we're going to mess with this number a little bit as time goes on through the lesson. Okay? In this part of the lesson, we are calculating midpoint, right? If we weren't calculating midpoint, midpoint is the middle or the half. If we weren't calculating midpoint, we would change those values that I just underlined with a squiggly. But let's not spoil the fun and move on. I already sort of spoiled the fun. I didn't look at the next question. Why do you think all the formulas have 1/2 in them? Well, because we were finding the midpoint. The midpoint is half the distance oh, for goodness sakes. Between 2 points. Okay, that's why we used half. Okay, it's halfway between the endpoints. What if we wanted to find the point that is 1/4 of the way along AB, closer to A than B? How would the formula change? How would you represent this on the graph? So instead of 1/2, I would use 1/4, right? I would divide the horizontal and the vertical distance into 4 equal segments, starting at endpoint A. I would count 1/4 of the way from A towards B. Let me get a picture. So 1/4 of the way would be 1, 2, 3, 4 from A. So that would be my point 0, 7, right? So on the graph, super easy. I don't want to graph everything that I do though, because that takes time. So I would just count 1/4 of the way over from A towards B. Cool. But let's do this writing a formula. So for my x value, I'm going to have -4 plus 1/4. 12 minus -4. And that in fact equals 0. And for my y value, I'm going to start at 5 and add 1/4 of 13 minus 5, which equals 7. Now I can't actually use the midpoint formula for this because what's the midpoint formula? What's a word in the midpoint formula? Midpoint, which is halfway. Since I'm not going halfway, I can't use the halfway formula, right? Okay, just wanted to point that out. So this other fun formula that we've developed during this lesson works for any distance from A to B, as we can see by this one. Now find the coordinates, now find the coordinates of a point that sits 1/8 of the way along AB, closer to A than to B, and show how to get that point using the formula. So I can do x is -4 plus 1/8, 12 minus a -4, and y is 5 plus 1/8, 13 minus 5. That gives me a -2, we're going to check it in a second, and a 6. So 1/8 would be half of a 4th, so we're at -2, and 6. Perfect. So -2, 6. 0, 7. What is another way to state this problem using a ratio and the term directed segment? Those are the big words that we're sort of using during this lesson. Ratio and directed segment. I wrote the answer in here because that's a lot to write. So you find the point on the directed segment from -4, 5 to 12, 13 that divides it into a ratio of 1/7, 1 to 7. So if I have a segment, we're dividing it into 1 and 7, which 1 plus 7 is, oh, I wrote the answer as I said it. 1 plus 7 is 8. So that's an eighth. 1/8 and 7/8. Cool? All right, next one. Find the point on the directed segment that divides it into a ratio of 1 to 15, which is 16ths. So 1/16 and 15/16. And that's why you see here in the answer that I just copied, -4 plus, I've been writing it like this, 12 minus -4. And then the y value would be 5, 1/16, 13 minus 5. Cool? All right, that's sort of fun. All right, this is example 1. I didn't put the title in there, and for some reason, it's not in your classwork. Okay, so you can take notes or follow along. It's fine. So we're now going to apply this understanding of partitioning. Partitioning means breaking it up into pieces. Partitioning. Partitioning a segment proportionally. Proportionately. That was a hard one to spell. Proportionally is what they say. Ah. Alrighty, let's move on. So given points -4, 5, and 12, 13, find the coordinates of the point C that sits 2/5 of the way along AB, closer to A than it is to B. Alright, I just brought over the right picture. So can we find the coordinates of this point by finding the coordinates of midpoints as we did in the opening exercise? The opening exercise, it worked really well because I was using halves and fourths and eighths and 16ths, and that worked great. I'm breaking it into like 2/5, so 2 on one side, or yeah, 2 on one side, 3 on the other. It doesn't quite work. The opening exercise was great when you are doing powers of a half, so I can use successive midpoints to identify the coordinates of these points. So it's not going to work if the point is 2/5 of the way along the segment. So yeah, we showed you the easy way first, and now we're going with the hard way. But can we use proportions to find the point C? Well, yeah, I can. So let me draw a little bit. Not sure. It's not going to let me. Sorry. Hold on. Let me move I have a template over there I need to move. Be right back. Okay, I'm back. And my controls are all flipped, so I'm probably going to make a few mistakes. I wasn't able to draw this line because it was too close to the edge of my screen. Alright, so can I use proportions to find the coordinates of point C? I can. So if this whole length is 16, the whole length of the bottom is 16, and this whole side is 8, I'm trying to find 2/5 of 16. So 2 times 16 is 32, divided by 5 is 6.4. Yeesh. So I'm trying to go, that's 4, 5, 6. 6.4 over. And 2/5 of 8, 2 times 8 is 16, divided by 5, 3.2. So I'm going up 1, 2, 3, and a little bit. That is 3.2. So I can use proportions, and it works great. I just don't have happy even numbers. Let's see. I'm not sure where to write this in, so I'm going to write it right here. So my x term is going to be -4 plus 2/5 of 12 minus a -4, which is 16, and that gives me 654.4 for my x value. And then my y value is, I started out with 5 plus 2/5 of 8, 13 minus 5. And that gives me, let's see, 5, 6, 7, 8.2. So my values are 4.4 and 8.2. So 2.4. Wait a minute. 16, -4 plus 16 is 4.4. My bad. Or 2.4. I said it wrong again. You wouldn't think I could say it wrong that many times, but I have proven you incorrect. Oh, let's erase that over there. So if I go over 2.4 and up, I'm about right there. That's awesome. That's my ordered pair. 2.4, 8.2. Phew. Can you use what we learned about slope to verify that point C lies on segment AB? Yep, segment AB is a slope of 1/2. So I go up 1 over 2, up 1 over 2. Let me get a highlighter out. So to get from here to the points, I'm actually going to move over 6.4 and up half that. So I can move over 1, 2, 3, 4, 5, 6.4, and then up half of 6.4, because that's my slope, 1, 2, 3.2. So I can verify it with the slope pretty easily. Maybe not the easiest method to use, but hey, if slope makes sense to you, you can totally do that. And then how can we relate this idea to our work with similar triangles? Let me finish this. So similar triangles right there. So similar triangles, I've got 2 right angles here. It shares this angle, and my sides are proportional because I calculate them that way. So I can use angle side angle of similar triangles to verify that they are in fact similar, and it works well. Okay, let's try again. But now we are going to try to find point D. So we still have the same points A and B, but we're trying to find the coordinates of point D, which sits 2/5 of the way along AB, closer to point B. So I've got A and B. We found C, which was 2/5 of the way along, but closer to point A. Now we're finding point D, which is 2/5 of the way along the segment, but closer to point B than it is to point A. So let's use the same math that we did in the previous slide, and it'll be awesome. So the first thing I'm going to do is try to find value x, and I'm going to start up at point B and move my way down. So I'm going to do 12 minus 2/5 of 12 minus a -4. That's going to be 12 minus 2/5 of 16 was what? 6.4. And then that's the x term. The y value is going to be, my y value up there is xy, 13 minus 2/5 of 13 minus 5, which is going to be 13 minus 2/5 of 8. 2 divided by 5 times 8 is 3.2. Of course, it's half, duh. So that gives me a value of 12 minus 6.4. 5.6 is my x-coordinate, and my y-coordinate, 9.8. That is point D. The other thing that I can do is start at point A and add up, and it'll be okay, right? I can start at point A and add 3/5. Oh, not 3/2. 3/5 of 16. Start at A, which my y value for A is 5, and add 3/5 of 8. Okay, let's calculate that. 3 divided by 5 times 16. Oh, of course, it's 9.6. Don't judge me. That gives me the same answer and the same answer. So this is a great method. I don't know, I think it's pretty easy than what I used to do. So that's why I wanted to go through the tedious work of showing you how this works. Right, what we just finished with example 1 is called a part-whole ratio. Okay, it makes sense because I was doing 2/5, right? So the fifths was the whole, the 2 was the parts. That was example 1. Now I'm in example 2, which I know still isn't in your classwork, and I'm sorry. Now we're going to do a part ratio. So here I'd label it like 2 to 3, which if you add those together you get 5, right? These are the same, just written in different ways, like equivalent fractions. So let's try that one. Given points 10, 10 and 0, 4, find point R on segment PQ such that PR over RQ is 7/3. Okay, so I'm going to draw a picture. I'll be right back. That's a pretty awesome picture, if I do say so myself. So in previous examples, we were comparing the distance from the new point to the entire length of the segment. Now we're comparing lengths of the two parts of the segment. So the length of PR and the length of RQ. Point R is what we're looking for. It partitions the segment PQ. I should label that PQ. I'm looking for R. So it partitions the segment PQ so that PR is proportional to RQ 7 to 3. Okay? This means that PR to PQ, which is the whole, is 7 to 10, and RQ to PQ, the part to the whole, is 3 to 10, right? So let's do it. I'm going to move from P. I'm going to move up. I like to add, right? So I'm going to move up, but I labeled these wrong. That's a Q, and that's a P. Sorry about that. So I'm moving up from Q. So for my x value, I'm going to have 0 plus 3/10 of my total x value is the length of 10. And then I'm going to have 4 plus 3/10. My total length is 6. Right? Oh, for goodness sakes. Hold on. I tell you guys, some days. Alright, fixed the graph. Tried to use the whiteout that I have on an iPad. So I have my x value as 3/10 of 10 plus 0, so that's a 3. And then 3 times 6 is 18 divided by 8. Sorry, 18 divided by 10. 3 times 6, 1.8, plus 4, 5.8. So I have my new value. And life is grand, right? Sorry about that mistake. But my value for, I'm going to go over 3, 1, 2, 3, and up 5/8. 1, 2, 3, 4, 5, and a bit. That is R. And this is 3 to 7 is my ratio. Awesome. That's it. I'm going to do some exercises now. Not exercises, but like problems. Alright, now we get to practice what we just spent so much time learning. I put graph paper there to help in case you needed it, but I don't need you to feel like you have to do that. I'll graph them really quick. Okay, find the midpoint. We can use what I originally told you, which was do the sum of the x's divide by 2 and the sum of the y's divide by 2, because you're just finding the middle of the x and the y. 10, 9, 8, 4, 8, 7, 6, 5, 4, 2. And then you can check it really quick. 1, 2, 3, 4, 1, 2. When in doubt, make your dot bigger. Just kidding. So that is my midpoint. Cool. I can also do this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Midpoint. Awesome. Okay, next one. Find the point on the directed segment from -2, 0 to 5, 8 that divides in the ratio of 1 to 3. I'm not going to graph it really well. I just want to see where all my points lie. So over 5, up 8 is somewhere up here. So I need a ratio of 1 to 3. That means that I'm a fourth of the way from the bottom, from -2, 0 to 5, 8. So I just want to see where I was at. So I'm going to do -2 plus 1/4 of 5 minus the -2. That's my x value. And then 0 plus, that should not be 1/2. Sorry about that. 1/4. Plus 1/4 of 8 minus 0. So that's my x value and my y value. This x value, I've got -2, 5, 6, 7 fourths. And my y value is easy. That'd be a 2. Still simplifying, -1/4, comma 2. And then you can eyeball check it. I'm going to go -1/4 up to, yeah, pretty good. Okay, given PQ and a point R that lies on PQ, such that point R lies 7/9 of the length of PQ from point P along PQ. So point R is going to be somewhere on that end of the segment. We can just sketch an idea, right? Now is point R closer to P or Q? It's closer to Q because it's more than halfway. Along the segment. Okay, we're going on to part C. Use the given information to determine the following ratios. So PR to PQ, I'm going to sketch again, PQR. And our ratio they gave us in the problem was 7 ninths. So this would be 7, that would be 2, right? All right, so PR to PQ would be 7 to 9. RQ to PQ would be 2 to 9. I got that just from here. So part I is PR to PQ. So PR is 7 to PQ is add them together. RQ to PQ. RQ is 2. PQ is 9. Now PR to RQ. PR to RQ is 7 to 2. And then RQ to PR. RQ to PR is 2 to 7. If the coordinates of P are 0, 0, and R are 14, 21, what are the coordinates of point Q? Oh, no, bad, sorry. R was 14, 21. What are the points of Q? Q we can say is x2, y2. Let's use our formula. I do where I start plus 7 ninths times x2 minus 0 equals 14. And then I go 0 plus 7 ninths, y2 minus 0 equals 21. All right, luckily we have lots of zeros, so 7 ninths of x2 equals 14. I'm going to multiply 14 times 9 divided by 7. Oh, that was silly. That would be a 2, and that's 18. And then here, I have 7 ninths times y2 equals 21. So multiply by the reciprocal. That gives me y2 equals 27. So my ordered pair is 18, 27. We've got some algebra into our geometry. Cool? Okay, I have one more example. If you're feeling pretty comfortable, though, you may try your problem set. But if you'd like one more example, let's do this. So I've got a robot is at position 40, 50 and is heading towards the point 2000, 2000. So really basic sketch, 40, 50, 2000, 2000. Heading that way. Along a straight line at a constant speed, the robot will reach point B in 10 hours. What is the location of the robot at the end of the 3rd hour? So that would be 3/10 of the way, right? So to calculate that, I'm going to have 40 plus 3/10, and then subtract your x values. And then the y value, I start at 50 and calculate 3/10 of the distance. So that is where my robot is. What is the location of the robot 5 minutes before it reaches point B? So I have 10 hours for the total travel time. Subtract 5 minutes would be 9 hours and 55 minutes. So that really means we have 9 hours and 55 parts of 60, that fraction of our total distance. Okay, this is the total distance the robot has traveled out of the total distance that we have. So if you think about it, we're going right till about there. So the whole distance is 10 hours. We're traveling 9 hours and 55 minutes of it. So let me simplify this fraction. I'll be right back. This gives, oops, need a pencil. This gives me 119 over 120. All right, let's do it. So for my x term, I have 40 plus 119 over 120, 2,000 minus 40. And for my y term, I have 50, 119 over 120, 2,000 minus 50. Okay, let me crunch these numbers. Be right back. So there we go. I know exactly where the robot is. That's sort of fun. If the robot keeps moving along the straight path at the same constant speed as it passes through point B, what will its location be at the 12th hour? Weesh. So our sketch, I started out at point A, I went to point B, and this took 10 hours. What about 2 hours later? We already did point C, didn't we? Point W, like, what the heck are you doing? All right, let's look at it. The fraction for the 12th hour, I mean, if I went 10 hours, I'm now 2 hours past that, so I'm 12 over 10, which the mixed number would be 1 and 2/10, right? That makes sense. Or 1 and 1/5, but we don't need to go crazy or anything. 6/5. So that's what we're going to do. We're going past the end point. So 12 over 10 times this difference would give you a point further away from the end point. So there's my x value, and here is my y value. So our number should be greater than 2,000. So if I crunch that number, I get, oh, there's my parentheses, an x value of 2,392 and 2,390 because we went past our endpoint. Compare the value of the abscissa, the x-coordinate, to the ordinate, the y-coordinate, before, at, and after the robot passes point B. The x-coordinate is less than the ordinate. If you look at value at A, this would be A because we were before point B. For part B, we're not quite at, we're almost at. They should be equal. The x and the y should be equal when it's at point B. And then beyond point B, the abscissa would be greater than the ordinate. But really, it's all good. The value of that question is not as great as the value of the other questions. And then part E, could you have predicted the relationship you noticed in part D based on the coordinates of A and B? Point A, my x value was less than my y value, right? And point B, my x was equal to my y. So, I mean, we named it point what? My x would be greater than my y as we move on. Makes sense? It's all good. Good work today. That's actually all I have.